Hello, welcome to the Calling School. Please do subscribe and share. In the previous video, we talked about the indicators, universal indicator, we talked about commercial indicators, phenolphthalein, methyl orange, litmus solution, and the blue-ray litmus papers. So today, I want us to talk about a practical on the same. So let's dive into it. We have some solutions over here. We have, this is water, this is hydrochloric acid, this is ethanoic acid, this is ammonia solution, this is potassium hydroxide. We'll start with this. This is a red litmus paper, this is a blue litmus paper, and also we have litmus solution over here. So let me remove this so that you can't get distracted. This is a universal chart. There, let's leave it there. Okay, good. So we will pour some water here. So remember, this is water, hydrochloric acid, this is an acid, so this is neutral, this is an acid, and this is a base. Good. We start with the red litmus paper, then blue litmus paper, then litmus solution. Red litmus paper in a neutral substance. As you can see, the red litmus paper remains red. Red litmus paper in an acid. Red litmus paper remains red. Red litmus paper in a base. The red litmus paper turns blue. Let's talk about the blue litmus paper. Blue litmus paper in a neutral substance remains blue. Blue litmus paper in an acid turns red. And a blue litmus paper in a basic solution, in a base, it remains blue. Litmus solution in a neutral substance, as you can see, it's purple. So litmus solution is purple, or in any neutral substance it turns purple. Litmus solution in an acid, as you can see, it is red. Litmus solution in a base is blue. That's good. Okay, so what have we learned about the litmuses? The litmuses, as you can see, the litmus papers, the blue and red, are blue in a base. In an acid, the blue and red litmus paper are red. In neutral, the blue litmus paper remains blue and the red litmus paper remains red. Okay, let's move them. Nothing we can talk about here is we can talk about about methyl orange. So let's empty this, because add water there, add hydrochloric acid there, add potassium hydroxide there. We want to use methyl orange. Methyl orange is over here. So we talked about, this is the chart for the litmus. Acids, litmuses are red. And bases, so simple, the litmuses are blue. Methyl orange, that's the chart over there. So methyl orange in a base, so this is our base. Very good. As you can see, methyl orange in a base, it is yellow, turns yellow in a base. Methyl orange turns yellow in a base. Let's have some drops in an acid. Very good. As you can, okay, so let's talk about phenolphthalein. As you can see, we are expecting colorless and then we're expecting pink. Yeah, good. Let's empty this and add some new solutions. Let's add some water here, an acid over there, and a potassium hydroxide there. Phenolphthalein is here. As you can see, phenolphthalein turns pink in a base. Phenolphthalein in an acid, as you can see, remains colorless. And also in a neutral substance, phenolphthalein remains colorless. Okay, we can talk about, we've talked about those. So I want us to talk about the universal indicator. Universal indicator. Let's empty this first. We add water here. We add hydrochloric acid. We add ethanoic acid. We add ammonia solution. We add potassium hydroxide. So first of all, let's use the pH meter. This is sophisticated. So let's start with this. We dip in there. Oh, nothing shows. Good. Let's dip it here. This is potassium hydroxide, and as you can see, it has a pH value of 14. We have ammonia solution, a pH of 11.61. So this 14 is a strong base, 11 is a weak base. Then let's go to this. 2.38. 2.38 tells us that this should be a strong acid. It should be strongly acidic. Should be strongly acidic. But let's see the others. Okay, good. As you can see, the pH value of this is 0. And remember, this is hydrochloric acid. It has a pH of 0 because it's a strong acid. So it's strongly acidic. The next one over here, this is water. Has a pH value of 7. pH value of 7, meaning that this is neutral. So this is neutral, strongly acidic, weakly basic, strongly basic. There's nothing there, so that is a control. Good. So let's talk about a universal indicator. So we have a universal chart over there, and we have this, which is our universal indicator paper. What we'll do, we will dip the universal indicator paper in the solution and match it over there. So let's start. We dip it there. Remember, this is water. As you can see, it turns green, and that is neutral. So the pH value of this solution here is 7. And remember, this was water. Okay, let's take another, dip it over there, match it. As you can see, it takes us to the pH value of 1. And as you can see, and if you remember very well, this is hydrochloric acid. Okay, take another, so like that. Take this one. Just a moment, I think there's something wrong here. Good. We take another one over here. Good. As you can see, this matches with 3, matches with 4, I don't know. Okay, matches with 4, meaning that this is weakly acidic. Is it 4 or 3? This is ethanoic acid, so theoretically we know that it should be weakly acidic, and it gives us around 4 there, number 4, the pH value of 4. The next one, this is ammonia solution. Theoretically it's weakly basic, and as you can see, it gives us a pH of, no, this 9 or 10. It gives us a pH value of 10. Of 10 there, 10 or 11, 10, around 10, around 11 there, around 10 9, 10, 9, 10. Okay, we have another here. So you can see this is potassium hydroxide, is a very strong base, so we say that it is strongly basic, gives us a pH of 14. What have we learned today? So today we've learned about, we've seen that the blue litmus paper remains blue in a base, remains blue in neutral substances, and turns red in an acid. We've also seen that the red litmus paper remains red in an acid, remains red in a neutral substance, and turns blue in a base. We've seen that litmus solution turns purple, or it's purple, so when you have it in a neutral substance, it retains its color, which is purple. It turns red in an acid, and it turns blue in a base. We've also seen that methyl orange turns pink in an acid, and it turns yellow in a base. We've also seen that phenolphthalein indicator remains colorless in an acid and turns pink in a base. And we've also known how, we've seen and we've observed and we've understood how we can find the pH given the pH universal paper and the solution and also the chart. So I believe this was helpful. I'm hoping to see you next time. Please share, subscribe. Yeah, stay safe. See you soon.